This is Geometry, Unit 3, Lesson 10 on using the formulas. We have learned a lot of new formulas for coordinate geometry, and we have to know when and how to apply them. So let's look at some important problems and figure out what formula we need and how we would use it. So our first one is for congruent. What does congruent mean? It means the same length. So to show that two line segments are congruent, we have to use which formula? Well, congruent means the same length. We would have to use the distance formula. So the distance formula says if the distance is the same, then the segments are congruent. So for example, if I was looking at this triangle and I wanted to show that the segments were congruent, say I wanted to say that AC was congruent to BC, I would have to use the distance formula, which is D equals the square root of delta x squared plus the square root of delta y squared for the distance formula. So if I wanted to prove that AC is congruent to BC, use the distance formula on AC, on AC, and BC. So if I'd use the distance formula on AC and BC, if the distance is the same, we can say AC is congruent to BC. So use the distance formula. You'd have to know what the coordinates of A, B, and C are, find the distance of each one, and see if they're the same. If they're the same, we can say they are congruent. The next one we want to look at is parallel. If we want to show that two line segments are parallel, what do we have to use? Well, what do we know about parallel lines? Well, they have the same slope, so we would have to use the slope formula. If the slopes are the same or equal, then we could say the segments are parallel. All right, so in our picture here, if we wanted to prove that two segments are parallel, it kind of looks like A, B, and C, D. So the symbol for parallel is a little arrow symbol like that. That means parallel, not congruent. So we would have to use the slope formula. So the slope formula, remember, is delta y over delta x, or y2 minus y1 over x2 minus x1. And what we would have to figure out, if A, B, and C, D have the same slope. Then AB is parallel to CD. So you would have to know the coordinates of AB and CD and figure out their slope. So you'd have to figure out the slope of AB and the slope of CD. If they are equal, then AB is parallel to CD. So you'd have to use the slope formula for that. All right, what do we know about perpendicular? Well, we know if two lines are perpendicular, we would have to use the slope formula again. What's special about perpendicular line slope? If the slopes are opposite reciprocals, then the line segments would be perpendicular. So if I was looking at my triangle over here and I wanted to see if two line segments are perpendicular, it kind of looks like AC and BC are perpendicular. So if I wanted to prove that those two lines are perpendicular, I'd have to use my slope formula, delta y over delta x. And we would have to say if the slope of AC and the slope of BC are opposite reciprocals, then we can say AC is perpendicular to BC. So we have to use the slope formula and show that they are opposite reciprocals, so AC is perpendicular to BC. And the last formula that we have is bisect each other. Now, what does bisect mean? Well, bisect, remember, means that it splits a segment into two congruent segments. Now, if two segments bisect each other, what point would they have in common? Well, they would have this point in common, and if it's bisected, what part of each segment is that? Well, that's the midpoint. So to show two line segments bisect each other, use the midpoint formula. And if two segments have the same midpoint, then they bisect each other. So if we are talking about this, now let's say this is M, my point M, we would have to use the midpoint formula, which is the sum of the coordinates, the average of the sum of the coordinates, so it'd be x1 plus x2 divided by 2, and y1 plus y2 divided by 2. So we'd have to use that midpoint formula. And if the midpoint of AB and the midpoint of BD, or AC, I'm sorry, that should be AC, not AB. The midpoint of AC and the midpoint of BD are the same, then AC and BD bisect each other. So all you have to do is find the midpoint of each of the segments. And then if they do have the same midpoint, you can say those segments bisect each other. And that's what you have. So those are your four basic ways that we use our formulas. We have slope, we have distance, and we have midpoint, and they're all used in different ways. So let's look at a couple of applications. Now for this problem, we have triangle ABC has vertices -3, 4, which is here, 5, 0, which is over here, and C is at -2, 4. Those are my three coordinates. Now, I want to show that ABC is an isosceles triangle. Well, how do we know a triangle is isosceles? It has two congruent sides. So, an isosceles triangle has two congruent sides. So in order to prove that two sides are congruent, which formula would we have to use? Well, to prove congruent sides, we would have to use the distance formula. They'd have to have the same length. So we have to find the length of the sides of the three segments of the triangle. So let's see what we have. Let's start with AC, using the distance formula. All right, so for the formula for AC, remember distance is equal to the square root of delta x squared plus the square root of delta y squared. Or you can use the Pythagorean theorem on either one. But let's look at AC. Let's use the distance formula. The distance between the x's, all right, so it's going to be -2 minus -3, watch your signs there, squared, plus 4 minus -4 squared. All right, so -2 minus -3 is 1 squared. 4 minus -4 is 8 squared. So that's equal to 1 plus 64, which is the square root of 65. Now we can leave it like that for a second. That's perfectly fine. Now, let's try the same thing with BC. We're going to use the coordinates for B and C. So the difference between the x's would be -2 minus 5, quantity squared, plus 4 minus 0, quantity squared. So I did this one minus this one. It doesn't matter the order that you do it as long as you're consistent. -2 minus 5 is -7 squared. 4 minus 0 is 4 squared. So that would be -7 squared is 49 plus 16, which is equal to square root of 65. Okay, so I've already proved that those two sides are congruent. So, just for argument's sake, if we did AB, just to make sure the third side isn't equal as well, let's do AB. Using the coordinates, we have 5 minus -3, watch your signs, and 0 minus -4. And we have 5 minus -3 is 8 squared, 0 minus -4 is 4 squared. So that is 64 plus 16, which is the square root of 80. Okay, so looking at our two values here, we now have to show that triangle AB is isosceles. Now, just writing this down here, I haven't finished it yet. I have to specifically say what makes this isosceles. AC is congruent to BC by our work up here. These two right here were congruent. So AC is congruent to BC, and isosceles triangle has two congruent sides. So triangle ABC is isosceles. All right, so my work up here shows me that AC and BC are congruent. I prove that this side and this side are congruent, so ABC is an isosceles triangle. You have to show the work that proves it and also write in a conclusion. So when you do a coordinate proof, you have to be very specific. Notice here when I did the distance formula, I put exactly which one I'm putting down, I'm finding the distance of. The person reading this has to know what you did. So be very careful of that. We also have a new vocabulary word here. A median is a line segment drawn from a vertex of a triangle to the midpoint of the opposite side. The word median kind of implies middle. So when you have a median of a triangle, you draw from a vertex to the midpoint. So if I wanted to find the coordinates of D on AB such that CD is the median of ABC, what this is asking you is, if CD is a median, it is drawn from C to the midpoint of AB. So if I go back to my picture here, here is C. I want to draw a line that is on, it hits AB at its midpoint. Well, we can see our midpoint is actually right here, but if we wanted to find it, that's my point D. If I wanted to find it algebraically, let me draw my line in, CD would be your median, like so. Let's find it algebraically. So the midpoint of AB is the sum of the coordinates divided by 2. So your points for A and B, A was at -3, -4, and B was at 5, 0. So the midpoint of AB will be at -3 plus 5 divided by 2, and -4 plus 0 divided by 2. -3 plus 5 is 2, divided by 2 is 1. And -4 plus 0 is -4 divided by 2 is -2. So D would be at 1, -2, because that is the coordinates of the midpoint of the opposite side from C, and you draw C to D. Our last new vocabulary word is an altitude. Altitude is a line segment drawn from a vertex of a triangle perpendicular to the side opposite the vertex. An altitude is also called the height of the triangle. So what we want to know is, to show that CD is an altitude of ABC, what do we have to prove? We would have to show, if CD is an altitude, then it would be perpendicular to the side it's drawn to, which would be AB. So how would we prove it's perpendicular? Well, perpendicular, you prove slope. So let's figure out the slope of AB. All right, using our coordinates for AB, delta y over delta x, it would be 0 minus -4 over 5 minus -3, which is 4 over 8, which is 1/2. And then we want to figure out the slope of CD, which would be, using your coordinates you found, -2 minus 4 over 1 minus -2, which would be -6 over 3, which is -2. So is AB perpendicular to CD? Yes, it is. AB is perpendicular to CD because they have opposite reciprocal slopes. You write that down. And that makes CD is an altitude to AB.